Hello, welcome to part 21, the long-awaited part 21, in the video series following the restoration of our 2-foot gauge Fowler narrow gauge locomotive, Tully Sugar Mills number 5, works number 16341. This is my face. You've probably heard me narrating the videos, but I thought I would start this one with a video of me because obviously there's an apology, because we've been 9 months since we made our last video, and the reason for that, as many of you will know, is that we took a sabbatical from the locomotive restoration to build a 10.25 inch gauge electric locomotive, fully lithium ion regenerative braking, high volt,
bang up to date
electric locomotive. And that took all of our energies for quite a long period of time. But we didn't stop completely on the engine. This has been ticking over in the background. As you can see, I'm standing next to the side tanks, and the cab is in the background there, and various other things have been done. So without further ado, we're going to pick up where we left off in part 20 with a little bit just finishing off the pony truck, which is virtually finished in the videos, and then we'll move on to other things, and hopefully it won't be so long before we're back with part 22 after this one.
So, looking at the end view of the loco, we are obviously back to the bogie again. So, looking here, this is the main casting, which, if you've seen the other videos, you'll remember, quite a complicated, large, chunky casting. And then down at the bottom, there's two little dowel pins that go through those holes, that go through holes in the casting, straight into the bottom keep for the axle box shell. You can see the two holes there just above the new foot that we welded on in a previous episode. If you look at this brass bar here, all you're looking at there is a brass bar pushed through the original hole, and you can see that it's not square. It tails off wildly to the left there. So we had to make a decision whether we lived with that or whether we tried to square them up by boring the holes out a little larger and putting an overscale pin in, an oversized pin in, which ultimately I decided we couldn't live with the wonky angle, so that's exactly what we did. This is Neil putting the long oversized drill through for the new pins. We've encountered this a few times with the rebuild, where holes that were obviously the original holes drilled in the Fowler works weren't entirely square or true, but I think the sort of drawings were more like guidelines than rules at the time. And essentially, I think when you're trying to do it as a business, as Fowlers were, then speed was important. So I think it needed 2 pins, and it just got 2 pins. But for us, we're trying to do a slightly better job, and that's why we've gone to this trouble to open it out to put fresh ones in. This is the oil pot lid from the top of the oil well that feeds oil through the wick feed lubricator into the top shell for the bearing. The lid itself was fractured. The whole left-hand lug there was missing, so we cast iron welded on a lump and refiled it to the original shape. Here Neil is reaming out the holes for the pin. A new pin will be put through there, straight through the mended cover, which you can see here has now been painted, and then the whole thing reassembled, ready for oil.
I think that's enough to get in. Yeah.
Another slightly different bit. This is where the large casting fastens onto the pony truck A-frame. There's a pivot pin at the end, which is what you see here, and there's a bracket that bolts onto the bottom of the frame stretcher to hold that pivot pin. The bracket's rectangular, there it is, and it's onto the frame stretcher, and obviously the pivot pin goes straight through the centre. This is a jump back in time to when we chopped off the rusted bolts to drop that bracket off the bottom of the frame stretcher. This is the bracket with the pin in it. The pin was extremely well worn, and so we chopped the pin out, we bored the holes, we've then rigged the bracket and the frame stretcher together to line them up in the correct position, and then we're boring the 2 holes together here so that they're concentric. You can obviously see that the frame stretcher and the bracket were previously fully bead blasted and restored. They don't look anything like as messy and rusted as they did when we took them off the locomotive. You can see the bores are now concentric, so a brand new pivot pin was made, and this is Mark welding the pivot pin into the bracket itself. The bracket is removable from the frame stretcher, and it removes with the pin, as you initially saw with Jenny holding it earlier when it first came off the loco. It's fully welded in, and that's effectively how you fasten the pony truck onto the bottom of the locomotive, allowing it to pivot left and right to go around corners. And then of course the finished stretcher and finished bracket were all filled and sanded and primed and painted, and that's what you see here. The central casting is finished and painted, the frame stretcher in the background, and the bracket for the pivot pin over there. You can also see the smokebox front ring in the background, but they're the parts ready to go back on. Back briefly to the last part of the pony truck assembly. The bronze shells, you see there's a gap there to the right hand side between the shell itself and the fatter part of the axle, as you see there. That's to allow lateral movement sideways so that things don't get tight. Just enough to allow it to wiggle around a little bit and remain free. But unfortunately, there was a little bit too much movement there. We're going to make a collar, which is what this is being chopped from a large diameter steel bar, to restrict that lateral movement. It was actually a mistake. We initially cast the shells to the pattern that we made to the original drawings without actually thinking about the wear levels on the axle, and they turned out to be quite significant. So our shell left that gap. We looked at remaking the pattern, making new shells that were half an inch fatter, but ultimately decided that a better working solution was these collars. The surface area on the side face of the collar is significantly larger and will rub against the shells, and so it represents a better bearing surface to resist that lateral movement. If we just left the axle slightly fatter as the bearing surface to rub against the shells, it only pokes up onto the bottom surface of the shells by about 1/4 of an inch, and therefore would be significantly more prone to cut into the bearing shell. The collar was then cut into 2 halves, which you'll see being fitted to the axle later. This is the assembly, the final assembly of the pony truck unit. The whole thing's upside down in this shot. You can see at the bottom there, the top shell is already in, the axle sitting on top of it. And in goes the bottom half of the bearing. That one doesn't actually touch the axle. It touches down on the top shell, which keeps it 15 thou off the axle itself, just enough for the pad that it has in it to hold the oil and just wet the axle as it rotates in oil to make sure that it's constantly fed. There's 2 pins in each side. This is Neil bashing the pins into the holes that you saw being bored on the milling machine earlier. Both pins have got a washer and a split pin in them so that they're easy to remove but retained safely. They just push all the way through, and then as I say, there'll be a pin and a washer through on the end as well. This is the ones going in on the other side. If you look there to the left of where Neil's bashing the pin in, you can see the gap between the pony truck casting and the wheel. Same here, you can see it both sides. Well, that's where these collars go that we machined earlier. Here's Neil fitting them, so that there is the top of the collar and the bottom of the collar for one side, and the same for the other side. They straightforwardly clamp solidly to the axle itself. They rotate with the axle and the wheel, but the inner face rubs on the bronze bushers, just a large flat face to spread the load and rub on that bronze face. So this is just a quick look back in time. This disassembly of the original pony truck is covered in an earlier video, but I thought it would be good before we show the finished article to show you what it looked like when it first came off the engine. As you can see, it's all pretty rusty. It had sat out in a field essentially for 60 years after it had finished being used at the sugar mill. The wheels were obviously returned, again the subject of an earlier video, and the whole frame and pony truck was stripped right down. All the parts were bead blasted, everything's been refurbished, painted, and then all put back together. This is the finished article. That's the pivot point with a new bronze bush in it on the A-frame that fastens onto the bottom of the main pony truck casting. The whole thing will get a last touch-up of paint before it goes back on the engine, so the odd little scuff here and there is not a problem. Here you can see the collar permanently fitted in the gap there, bolted up, clamped tight to the axle. You can see the new feet there with the pins and the 2 little pins that hold the bronze bushers in. You can see here the bottom bronze oil cap and the top bronze shell over the top, and you can see them through the centre there as well, one on the left, one on the right. That's where the load's transmitted through into the engine, or from the engine to the axle. The main thread there sitting on the axle at the moment, it won't be, that lifts up because there's a spring goes into the main body of the casting there that we'll cover at a later video. And the main pivot point at the top is there ready to take the lever arm that again we discussed in a previous video. So that's the pony truck ready to go back on the engine. Now this next bit's going to shock some of you. If you look at the left hand side, this is the back of the loco frame, it dips down. It drops down by about 1.5 inches to the back left hand side. You can just see it there. Now this is because the frames are twisted. They're actually twisted on the back left axle box. Now at some point the horn guides that hold the axle box there have been refitted and straightened. You can see clearly here, if you look at the frame stretcher as opposed to the frame, you can see it drops down quite clearly. Now we didn't want to mess with the actual horn guide space near the axle box because that's already been fixed at the sugar mill, and we checked it and that's square. So we decided the best thing to do was to chop the frames behind that axle box. Quite a big decision because nobody wants to chop through a full set of original frames, but we decided we couldn't live with the dip because it would have thrown the whole foot plate and cab out, and we decided that we could do a proper weld repair up there that would be just as strong as the main frames. So that's what we're doing here. We're slicing through almost to the top, leaving a little portion of 2 or 3 inches at the top of the frame joined so that the actual length of the frame doesn't change. But if we split the whole frame right the way down there behind the axle box hole, that will allow us to lift the rear section of the frame up, which you can see here, the spirit level showing us how far down it's dropped at the edge. And if I lift the spirit level up to pull the bead into the centre, you can see at the edge how far down we are there. You can just see in the picture the chain attached inside one of the holes on the frame. That's on the overhead crane, and we're lifting on that. And the idea is that if we heat up the top portion that we haven't chopped through with the burner like this, it becomes slightly malleable, and we can lift with the crane and just allow it to split at the bottom of that whole split that you can see there, moving the 2 edges apart so it lifts the back end of the engine up back square, and when we've done that, we can then weld the whole thing back up again. So this is the laser level across the back. We've got it back level just above the top of the frame. Same thing there with Ian's hand. Same thing there with Mark's hand. And the same thing right up the very front. So we knew it was level all the way across, all the frame stretches, the top of the buffer beam here just behind the smokebox saddle. Again, it's right the way in the same position and horizontal all the way across. So we knew that everything was square, everything was in the right position. The crane is holding everything, or was holding everything up, now it's blocked in position. So now it's a time to clamp it all up and weld that hole up, which is now obviously slightly wider at the bottom than it is at the top. So this is weld prep. The actual cut slot is angled to 45 degrees on either side, on both the inside and the outside, and obviously front and rear. Again, there's no two ways about it. It's an extreme step, but we felt it was worth taking at this point because there was not going to be another opportunity to do that. And everything that we do from this point onwards needs to be on a straight flat surface for the footplate and the cab. So first thing to do is to lay down a root weld to stitch the two together. So you can see here there's a square tube welded and a threaded bar across the bottom of the frame and halfway up the frame. That's to keep the frames exactly where we wanted them. The threaded bar has nuts on it that allowed us to position the frame exactly where we needed it, and the square tube was welded in place to hold it there too. It allowed us to make sure that the surfaces were truly flush with each other as we welded it, and it allowed us to clamp it so that it didn't distort as we did that. You can see here, checking halfway through, the root weld is in, but we're checking to make sure with the flat edge that the two surfaces are still bang on level. You can see this is the weld going in to lay down some of the covering welds to fill in over the top of the initial root weld. It's all coded welding, so it's going to be extremely strong. It's boiler quality. So the hope is that the finished joint will be just as strong and stable as the plate was initially, but now we've got a truly square foot plate to begin building upon. The square steel tube that we put in to hold the frames where we wanted them just gets chopped out and the surface sanded back, and it served its purpose. The last couple of capping welds go in. This is just before the last coat of weld goes in. The whole lot will be ground flat finished before we painted it, and now we've got a square set of finished frames.
Well, thank you very much for watching again. Sorry it took so long to get it there. There'll be another one along soon, part 22 I think, is obviously going to start covering some of the cab work that we've done, restoring the front of the cab and the original bits, trying to splice as many original bits as we can. You can see the back of the cab here is partly original and partly new. So thanks again for watching, and we'll see you very shortly in the next part.